Watertok.
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 Water of the day.
We're doing the water of the day. We currently have unseasoned water in here.
Dr. Pepper water. We're making it, baby.
Ooh, that's sweet. It is a way of life. All the comments are like, if it's not clear, it's not water.
Y'all, it's good too. Like, it is good.
Hi, hello. Do you remember Watertok? If you don't, I'll add links to some videos at the end of the video so you can get a grip on what Watertok is, but you don't really need it to get this video. So don't leave, please. So hi, I'm Lux, and I'm late to the party. The whole Watertok thing happened 4 months ago at this point, but I thought I'd ask a different question. Since I'm not a funny commentary YouTuber, I'm not going to talk for 20 minutes about what I think about Watertok, because there's plenty of funnier people than me out there that make better videos than I do. Instead, as your resident STEM girly, I'll tell you about what science thinks about Watertok. Because as soon as I saw my first Watertok video and saw the discourse that happened in the comments of the video and saw everyone in the comments say that they couldn't call it water anymore, I wanted to see if there was an answer rooted in STEM that can help us to know who's right here and definitively tell us if we can still call it water or not. So I set out to make this video and I started my research, and oh boy was it a ride. So let me tell you what I went through to finally get the answer to the question. When can I not call water water anymore? So first, really, I started with our bestie, Google, who didn't help. Google sucks right now, FYI. When you're looking for very specific questions, not just looking for Facebook or YouTube or whatever, it'll get you there, no problem. If you're looking for specific questions that you might be sure if has an answer or not, Google's been having issues getting you to actually relevant results to get those answers you need. I don't know why. They're more keen on showing you sponsored results or other vaguely related results, or just tell you there's nothing out there, even though I know I've seen stuff out there that answers this question. Anyway, super annoying. We can move on to Google Scholar though, because in the chemistry field there must be some research, right? But no, couldn't find anything actually relevant either, so that's cool. But it does seem reasonable that there would be some metric for how much we can add to water before it's not water anymore, right? I mean, we use water for everything. There must be a standard for this, right? So maybe I'm just bad at Googling. Maybe I'm the problem. Maybe Google sucks too much to help me answer this question right now. So I should try asking for help. So next step, I asked my chemistry lecturer, but she wasn't sure. So my chemistry professor happens to walk in and we ask him. Surely he must know. But he explains a few things about water and how it works, but when it comes to when we can call water water, he couldn't give me a straight answer. Because let me tell you some stuff about water. So, H2O molecule, better known as water, is made of an oxygen atom with 2 hydrogen atoms together make the water molecule. Easy enough. Water is the universal solvent, and we use a ton of solutions based in water. How do we name these solutions? We name them based on the thing that we dissolved in the water. And then the fact that water, in addition to being the universal solvent, is also pretty much the universal exception to the rules, makes it a little interesting, a little special. For example, water is the only liquid that expands as it freezes. Why does it do that? Great question. But even in chemistry, we never call a liquid that is in fact just water molecules, water. We specify that it's either pure water or demi-water or distilled water. We tend to name it based on the way that we made the water pure. Or if we're making equations, we just say water molecule. But then we're talking about one molecule. And we just never really just say water. So if in chemistry we don't really have rules for when to call something just water because we just avoid calling it just water, Can we find an answer anywhere? So is there someone else I could ask for help? Maybe if I ask our newer friend, ChatGPT, what would they say? Water is typically called water as long as it retains its fundamental chemical composition, which is H2O, 2 hydrogen atoms bonded to 1 oxygen atom. As long as a substance maintains this composition, it's considered water. And then it goes on to tell me a ton more AI stuff, but really it boils down to ChatGPT seems to think that only H2O is water, which I think is a little strict. Because if we consider drinking water, it also has minerals in it and it's not pure water. We never really drink pure water. So it feels like too much. I would think it's a bit too strict, because that would mean that water in our water bottles or the water we buy in grocery stores wouldn't be considered water. That's entirely too much, and that's not how we as people use it. So a robot not understanding how people use words is not the craziest thing. So all jokes aside, because taking ChatGPT's word for it is a joke, let's move on to something a little more trustworthy. So this year in university, materials engineering is also one of my courses, which, among other things, deals with the categorization of different materials. Usually metals and the sort, but my professor might know something that could help. So I asked him, and he talked about how we use standards to name especially metals. And as soon as it's not the pure metal anymore, it would be considered an alloy or would get a different name based on the concentration of the different elements that make the material. And as soon as it's not that pure thing, some names come with a range of percentages that the elements have to be in for the material to have that name. But these rules aren't really used with liquids, especially when it comes to water. Then he kind of brought up etymology, the study of words. And really, we could begin with the dictionary definition of water. The main consensus from different dictionary definitions is that water is a tasteless, odorless, colorless liquid at room temperature. Now, there's immediately some issues with this definition, starting with flavor. If you happen to be part of the Hydro Homies community, you know that water in fact has flavor. We can taste the difference between mineral water and distilled water. I definitely prefer some water over other water when it comes to what I drink on a daily basis. So if we want to include drinking water in this definition, which the dictionaries do include, it doesn't make much sense. So what about the odorless bit? I'd almost want to give it to them if it wasn't for the fun fact that I learned a little bit ago. So, you know how sharks are known to smell blood really well in water? So, where sharks can smell blood per 1 part per billion in water, humans can smell the presence of a single drop of rain at 5 parts per trillion. So, I'd want to try to help you visualize this. But, so, you know how you can see a dead pixel on an HD monitor or screen? Now, make the screen 100,000 times bigger and then have 1 dead pixel in it. That's how well we can smell rain. So as a crazy huge number or small number, I don't know, it's hard to visualize how big this number is. But okay, to be honest here, this isn't us actually smelling the raindrop. Really, it's just us smelling the effects of the raindrop. Humans happen to not have the receptors to smell water, but even pure water has a smell. We just don't have the receptors for it, but some other animals do. But we can smell the effects of that water. We've evolved to smell the effect of water very, very well. So I feel like the point still stands. Water has a smell. We technically can't smell it, but we can smell the presence of water. So another point eliminated. Moving on to the colorless bit, sure, water is see-through, so it doesn't have a color, right? Wrong! Water is a very light blue color. We just don't see it in small quantities, But when you look at glaciers, for example, you can see that it has a blue hue. The water freezing, shifting the molecules a little bit makes it a lot easier for us to see. But water has a color in large quantities. You can tell that seawater is blue. If you've ever been diving, everything's a lot more blue. So the only thing we're left with is that water is a liquid. So what if we look at all the things we call water that are currently not disputed? All the things we can be sure of and feel safe calling water, right? Well, fun fact, we call a ton of things water that are definitely a lot more than water, because we have seawater and salt water, which really is water that has a little bit of everything dissolved in it. So clearly a lot more than just water. Sweet water, which is technically still salty water because it has minerals in it. And we have drinking water, obviously. We have tap water, sewer water, bath water, rainwater, swamp water, groundwater, tons of things called water. And we have a tendency to look at them and say, yeah, that's water. I look at the sea and say, yeah, looks like water to me. I'm not gonna question it. And with some of them, if you compare the percentages of those liquids that are not water, they're more than you might think. And some of these things we call water are actually less water than some other things that we don't call water. Seawater, for example, is about 96.5% water. Sounds like a lot of water. This sounds like you can be very sure to call it water. Hydrogen peroxide that can be bought in stores, and which is an antiseptic that basically kills all cells it comes in contact with, is 97% water. And this percentage for seawater only includes the minerals inside of the water. It doesn't even include all the bigger stuff that's in the oceans. It doesn't include boats, plastic pollution, any other pollution, fish, other life forms, sand that's in there. There's a lot more there that isn't water that we don't take into account in this percentage. And then lots of fruits are also between 90 and 99% water. But we never call those water, do we? So do we just hold a very strong value to the liquid part of the water? Maybe. Especially looking at the fact that we don't actually call water in its solid or gas form water anymore. When it's solid, we call it ice. When it's gas, we call it steam or vapor. So this still doesn't give us a clear answer to when we can call something water or not. It just shows that we're a little inconsistent when naming things. So what if we look outside the traditional STEM courses and find research into what humans call water? A research paper from 1994 at Lay University in America by Barbara C. Malt. She asked the question, what makes a liquid water? She said that a strong version of psychological essentialism predicts that people use the presence of the H2O molecules as their primary reasoning to say if something is water or not. She also mentions that most people would probably say water is a clear, odorless liquid found in rivers and lakes which humans and other animals need to live. In her conclusion, she says that when people think 67% or more of the liquid is water, then people can call it water. This does depend on the source, current location, and function. So really, what people call water depends on what content they think of the liquid is water. Now, when going through the numbers, the contents people think of things are water are a lot lower than what they actually are. So saying that when people think 67% or more of a substance is water, they're talking about seawater and river water and the like, that they think only that small amount is water, making it that when people think most of a liquid is water, they can reasonably call it water. And fun fact to insert here, when writing the script for this video, Google Docs kept trying to correct the sentence "when is a liquid water" to "when is liquid water," seemingly saying that any liquid is water. So that's interesting. So combining everything we've learned, having to cut down our definition to water is a liquid, and Google Docs telling me that a liquid is water, and the research showing me that when it comes to people naming things, as long as we think that most of a substance is water, we get a new definition, which is water has to be a liquid. It should serve the function we normally associate with water, being drinking, swimming, life-giving, rinsing, etc. And it has to be believed to be mostly water. So really, anything with water as a majority solvent has the potential to be called water. Anything that uses water as a majority solvent can be called water. Watertok was right. So anything that's mostly water, we could just call water? I mean, this can be considered to be water. It's mostly water. This liquid bleach is, what? Less than 5% sodium hydroxide. More than 95% water. We can call this water. It's definitely not the answer I expected. It's all water. But I guess that's what science is about, isn't it? Undesired or unexpected results happen. And I would be doing you and science a disservice if I wouldn't actually make this video after I've done all the research and figured out what we can actually reasonably call water. I guess it is the most chaotic answer, which is fun. But currently there's clearly no real rules or guidelines as to when we can call these things water. And I mean, if bleach or hydrogen peroxide can reasonably be called water, something's off. Outside of the factor whether or not I want to believe watertok is right is really irrelevant at this point. So I figured I might as well do something about it. Not to stick it to watertok or anything, but if something we use every single day of our lives doesn't have any guidelines and can be reasonably conflated with something that could kill us, it should have guidelines as to when we can call it water or not when it has so much influence in our lives. It just feels off to not have it present. There should be a rule. Now, there are guidelines based on when we can call something drinking water, but that's also a lot of national regulation, and that's when something is allowed to be in our taps or not. There's no regulation as to what happens to the water after the fact. If I take a cup of water right now, I can add anything I want to it and call it water. So I contacted the ISO. In case you don't know, this is the International Organization of Standardization. They create guidelines or standards that are then used worldwide in different industries. These are the people that create the standards that we use. Now, I sent them an email telling them about what I found and how I feel there's a gap here, and if there would be a possibility for a new standard to be created to fill this gap. And creating a new standard, they explain it on their website, it takes about 3 years at least. So don't expect much of an update anytime soon, but I do hope to hear back from them. And it would be really cool if I could somehow be involved in something pretty significant like this. So that brings me to the end of this journey that I went on to try and figure out when we can't call water water anymore. I hope you enjoyed my suffering through trying to figure out an answer. Please feel free to check out any of my other stuff or give me other questions or suggestions that I should try to figure out. So thank you for watching. I think it's really cool that you did. And I hope I see you again next time. Toodles. It's all water. Wow.